Welcome to this explainer. Today, we're going to completely shatter the mental models we've all built up over a lifetime regarding dinosaurs. You know, we think we know them, right? Thanks to blockbuster movies and pop culture, our perception is, well, often a mixed bag of inaccuracies. But today, we're exploring the highly improbable reality of these incredible creatures. We're going to look at facts about their timeline, their sheer scale, and their living legacy that honestly sound completely impossible, but are an absolute verifiable reality.
Think about that for a second. What if the wildest, most unbelievable statements you could possibly make about our favorite prehistoric giants were exactly how history actually played out? Okay, let's dive into this because the true story of the dinosaur is far stranger and honestly far more fascinating than anything Hollywood could ever dream up.
Section 1. A World Without Flowers.
To really, truly understand dinosaurs, we have to grasp just how deeply disorienting their timeline actually is. I mean, they achieved a level of success that has literally never been seen before or since. They were the dominant group on this planet for over 165 million years straight. Just to put that into perspective for us, modern humans have been around for less than 0.2% of that time. And because their reign started so incredibly long ago, dating as far back as the Middle Triassic, roughly 234 million years ago, the vast majority of Triassic and Jurassic dinosaurs never saw a single flower or a single blade of grass. You see, flowers didn't even pop up until around 130 to 140 million years ago, and grass didn't appear until about 100 million years ago.
And this brilliantly illustrates just how different their daily reality was from ours. Think about it. If you were to drop a Stegosaurus into a modern meadow, it would probably be completely confused by the grassy, floral environment. The early Mesozoic landscape they navigated was mostly dominated by ferns, conifers, and mosses. It was this dense, rugged, entirely green and brown world, completely devoid of the colorful blooms and grassy plains that we just consider totally normal today.
But you know, it's not just the plants that were alien. These creatures are so unimaginably old that they technically lived on the other side of the galaxy. Our Earth, along with the entire solar system, is constantly flying through space like a bullet. Since the time the very first dinosaurs evolved, our planet has traveled through completely different galactic neighborhoods within the Milky Way. And on top of that, thanks to continental drift, none of the oceans and seas we know today even existed back then. The land masses would be absolutely unrecognizable to you on a map.
Their existence stretches across such a vast expanse of time that it creates some massive mental roadblocks for us. Here is one of my absolute favorites. There is a 76 million year gap between the existence of the Stegosaurus and the Tyrannosaurus rex. Why does it actually matter? Well, because the T-Rex went extinct 66 million years ago. That means that right now, as you're taking in this explainer, you and I live closer in time to the fearsome T-Rex than the T-Rex lived to the Stegosaurus. Let that sink in. Those epic movie battles between different dinosaur eras, yeah, they're about as historically accurate as humans fighting a Triceratops.
Section 2. Reading tiny bone fragments.
So, with their world completely gone, how do scientists actually figure out all these impossible facts? You'd totally be forgiven for thinking we need a complete, perfectly preserved skeleton to discover a new species. But the reality is, researchers can often identify entirely new dinosaurs from something as incredibly small as a single isolated fragment. First, they start by checking the density of the bone, which varies highly between different groups. Then, they look for autapomorphic features. Basically, these are distinct, highly unique structural traits that are found only in a specific group or species. And finally, they cross-reference and match these isolated fragments to known fossils.
Now, what's really interesting about this slide is how specific this gets in practice. Imagine an expert finds a lone, highly distinct serrated tooth just like the one you see here. If that tooth has the specific automorphic features of a Spinosaur, but it also contains new, distinct traits that don't match anything previously recorded, well, paleontologists can confidently declare the discovery of an entirely new type of Spinosaurid, all from just a single tooth. I mean, it sounds like absolute magic, but it's really just the incredible specificity of biology.
And technology lets us push these small fragments even further. By analyzing preserved melanosomes, we can actually deduce the real colors of certain dinosaurs. Fossilized impressions give us the literal physical texture of their skin. And perhaps most amazingly, we can use endocasts. These are the internal casts created by a brain inside a well-preserved skull. By carefully studying the size and shape of these endocasts, scientists can infer whether a creature like a T-Rex had an intelligence profile leaning more toward a modern crocodile or something much more complex.
Section 3. Scale of the giants.
When it comes to the physical animals themselves, you have probably heard this famous myth. It was popularized in the 1990s and partly spurred on by the novel Jurassic Park. It's the idea that if you average them all out, the typical dinosaur was really only the size of a dog or a sheep. Now, it sounds like a great trivia fact to bring up at a dinner party to sound smart, right? But here's the thing, it is completely false.
A comprehensive meta-analysis of the entire fossil record puts the actual average dinosaur weight at a whopping 4,282 kilograms. That is over 4 tons. So, forget the size of a golden retriever. Your statistically average dinosaur was roughly the size of an Asian elephant. It is literally an almost impossible challenge to randomly select a small species from their era.
To truly feel the weight of that statistic, compare that 4,282 kilogram average to the animals around us today. The average North American mammal right now is about 590 times smaller than the average dinosaur was. Think about that for a second. Life on land has effectively shrunk by nearly 600 times since the Mesozoic era.
And remember, that was just the average. Let's look at the real heavyweights. A modern giraffe is one of the largest land animals we currently have on Earth. Well, a Tyrannosaurus rex was a walking, bone-crushing machine that was over 5 times heavier than a giraffe. Even the largest duck-billed dinosaurs, which we usually just think of as gentle herbivores, could sometimes weigh well over 20 tons.
But absolutely nothing compares to the sauropods, specifically the titanosaurs. These were the true freaks of nature. A single fleshless leg bone of an Argentinosaurus is actually taller than an entire living elephant. And then there are the megasauropods. Based on recent studies, a creature like the Brouhathgaeosaurus may have weighed up to 170 tons. 170 tons? Let that sink in. A single lone individual of this species could weigh more than the entire global population of Siberian tigers combined.
It's so mind-bogglingly huge that for a very long time, people thought Earth must have just had lower gravity back then. But that is a complete myth. The real secret to their impossible size comes down to some brilliant evolutionary adaptations. We're talking hollow, naturally buoyant bones, highly efficient bird-like breathing systems with built-in air sacs, and specific, complex ecological factors that scientists are actually still trying to fully decode today.
Let's move to section 4 and see how this builds. Dinosaurs among us today.
Here is the absolutely craziest true fact of all. We always casually say the dinosaurs went extinct, but that is scientifically totally inaccurate. Against all of those popular misconceptions, the group never actually died out. Birds are not just heavily related to dinosaurs, or dinosaur-like. Taxonomically speaking, they are living dinosaurs in every single sense of the word. Scientists basically divide the family tree into 2 branches: non-avian dinosaurs, which are the extinct giants we've been discussing, and avian dinosaurs, which are literally the birds outside your window right now.
Feeling skeptical? This isn't just some wild fringe theory. It's backed by absolute mountains of independent evidence. Birds and non-avian theropods share exact structural details in their feathers that are just way too complex to be simple convergent evolution. They share internal traits like wishbones and hollow bones with air sacs. And for the ultimate undeniable proof, back in 2007, researchers sequenced a tiny piece of collagen protein from a 68 million-year-old T-Rex fossil. Out of all the modern animals tested, that ancient amino acid sequence most closely matched a common farm chicken.
And that leads to this deeply, deeply ironic truth. Because birds and the T-Rex both belong to the Coelurosaura group, which are the feathered theropods, a standard farm chicken is genetically more closely related to a Tyrannosaurus rex than a T-Rex is to an Allosaurus or a Giganosaurus, which were scale-covered carnosaurs. So all those epic movie matchups, genetically speaking, they're less accurate than pitting a T-Rex against a pigeon in the park.
So the crucial point is this: dinosaurs are still one of the most successful groups of animals alive today. There are over 11,000 known bird species around the globe, and over 99% of them are flyers. While they might not rule the land in the exact same way a 170-ton titanosaur did, making the statement that dinosaurs still rule the skies is a totally valid 100% scientific reality. Their rule never actually ended, it just took to the air.
It really makes you view the natural world entirely differently, doesn't it? The next time you see a flock of birds flying overhead, or even just a chicken, remember, you are looking at a creature whose ancestors lived on the other side of the galaxy, dominated the globe for 165 million years before grass even existed, and shrunk down 600 times just to survive. If over 11,000 species of dinosaurs are still thriving right above our heads today, what does it truly mean to go extinct?
I hope this explainer changed how you see the world around you. Stay curious, keep exploring, and I'll catch you in the next one.